Hello everyone, I hope you are all doing well. In today's class, I am going to introduce the second part of second unit is about processing text. As part of the search engines of the indexing process, we come to find one of the component in the indexing process, that is about one component is text acquisition, and the second component is text transformation, and the third component is the index creation. Can you guess this processing test is related with which component? Yes, the processing text is related with the second component present in the indexing process, that is about the text transformation. As part of the text transformation, what is going to happen? And as part of the text transformation, what are the things we are going to see? So we are going to see the contents present in the text processing here. If you observe, the contents we are going to cover as part of this section is one is about the introduction for the processing text, and we are going to know that how the words to terms from words to terms is going to be converted. How from words to terms is going to be converted. You have to imagine that what it is from words to terms. So you know that there are so many documents are there, each and every document consisting of a lot of textual information. So each and every document consisting of number of sentences, that includes a number of words. So all the words and the textual information present in the document is going to be converted into the terms. I hope you remember the word index terms. So that's about from words to terms. And we are going to know about the next one is about text statistics. Text statistics. What is text statistics? Here we are going to understand how many documents are there, if any document consisting of how many number of words and how many number of characters, and what are the frequencies of different words present in the documents. We are going to know about all of them in detail in the text statistics. And the third one is about the document parsing. So as part of the document parsing, we are going to study how the documents are going to be parsed. As part of the document parsing, we are going to study some of the concepts like tokenization, stopping, stemming, and these are all the different techniques we are going to study as part of the document parsing. Now we will see the first concept here, from words to terms. Try to understand here what is word and what is term. I already told you just now that words, the textual documents, the documents consisting of a lot of textual information, the entire text present in the documents are going to be converted into the terms. As part of it, what we are going to understand in a detailed manner. So here if you observe some of the points regarding to the processing of the text, you can understand that what it is. After gathering the text, immediately you need to remember the word after gathering the text. What is the first component present in the indexing process? What is the first component present in the indexing process? You know that indexing process it consisting of text acquisition and the second one is text transformation and the third one is index creation. What is going to happen as part of the text acquisition? Try to recollect. As part of the text acquisition, we know that it is going to identify the documents and store the documents from the web. Whenever a person is trying to search information on the web, what he is going to understand and what he is going to retrieve? He is going to retrieve the ranked list of documents. This is the thing happened. As part of the indexing process, when it is going with the text acquisition, whenever the user has entered a web search query, immediately the related web search query documents available on the web will be identified and they will be stored. After that process, there will be some modifications to the structures and some of the updations to the text present in the documents will be happened. So as part of that process only, we are going to talk about this processing of the text. After gathering the text, we want to search. The next step is decide whether it should be modified or restructured. Whether it should be modified or restructured in some way for simplifying the searching. Here, what you are going to do after gathering of the text, if you want to make the search simplify, you are going to make modifications and reconstruction for the text. You are going to make modifications and restructuring the text. And whenever you are making changes, so this process we are calling it as text transformation, or we are simply calling it as a processing text transformation or text processing. Here the types of changes that are made at this stage is called text transformation, or more often we are also calling it as a text processing. So here we are talking about this one in a detailed manner. Text transformation. What is text transformation? The types of changes that are made at this stage in the sense, after acquiring the documents, you store the documents. All the documents whatever you stored, you are making those documents text in a modified manner or restructuring. These changes you are going to apply for the documents. This is what we are simply calling it as the text transformation or text processing. Now, what is the goal of text processing or text transformation? As we know that all the text present in the documents is going to be converted into the index terms or the features. That is only the point you are going to observe here, right? The goal of text processing is to convert the many forms in which the words can occur into more consistent index terms. So as part of the text transformation, what is going to happen? Index terms are going to be created. Now you try to understand what is the importance of creating these index terms. What is the importance of creating these index terms? So here, index terms or representation of the content of the document that are used for the searching. So what the index terms are representing here? So they are the representation of the content of the document. They are the representation of the content of the document that are used for searching. So whenever you are performing searching operation, this index terms will play an important role for the representation of the content of the document. As we are very familiar with one of the best example in our laptops in our regular usage. So can you guess, whenever you are before the laptop or any desktop, you open one of the textbook or e-copy textbook you opened in your laptop. Then you want to find information about the particular word. How you can generally find the particular word or a particular topic while you are trying to search in the e-copy of your textbook? What you can do is you just simply search for the option, finding option or the search option you find. Accordingly, you will enter the word or the text whatever you want to search. Then obviously you are able to retrieve or able to view the documents whatever related for the word you entered. Now, if you see here, a good example of this is the find feature. Find feature in your favorite word processor. By the time you use the find command, whenever you use the find command, the text you wish to search has already been gathered. It's on the screen. On the screen it will be gathered. And next, after you type the word, you want to find the word, processor scans the document and tries to find the exact sequences of the letters that you just typed. What it is do generally, after entering the word, it is going to try to match whatever you have exactly entered, that is going to match the word with the documents what are available in the web. So these are all the things going to happen as part of this finding option present in the word processor. So here you are trying to understand whatever the word you simply type, that word related documents are going to be identified and the information regarding to the particular topic will be available. Here the exact sequence of the letters that you just typed, it is going to find the exact sequence of the letters that you just typed. So as part of the processing of the text from words to terms, these are all the points we are trying to understand, that the main thing you have to remember is you are going to make modifications in this stage after gathering the text. That's what we are simply calling it as text processing or text transformation. As part of it, you are going to generate the index terms. So they are representing, or they are for the representation of the content of the document that are used for searching. One of the best example is a word processor you are using in your laptop or your computer. Now, if you see here, one more point you have to understand. Whenever you are searching the information on your word processor, sometimes you may retrieve the exact information about the particular word, whatever you are trying to search for. But sometimes it may not retrieve, even though there are some little bit differences existed when you are in your search word. I hope you are understanding my point. The most annoying restriction is case sensitivity. Case sensitivity is one of the restriction here you are observed in some of the word processor. Suppose you want to find the word computer hardware. You want to find the word computer hardware, and there is a sentence in the document that begins with the computer hardware. I hope you observe the difference from this term to this term. What it is here, it is a small letter and it is a uppercase letter. Even though that content is available for that, sometimes it is unable to produce the information about it. So here there is one of the restriction, but as we see the popular search engines and most of the search engines are it is overcoming this problem while they are developing these search engines. So irrespective of the cases, they are going to extract the information with the semantics. So here this is about one of the restriction we are identifying. If you want to find computer hardware and there is a sentence in the document that begins with the computer hardware, your search query does not exactly match the text in the sentence because the first letter of the sentence is capitalized. So this is about this example. Next topic is text statistics. The word having the meaning that we are going to work on the text statistics. Statistics indicates some of the numbers regarding to the text. So you can try to understand whenever you observe so many documents consisting of a lot of textual information, in that text number of sentences are there, number of punctuation marks are there, different sort of textual information. Along with that you will be having some pictures and a lot of information is available in the documents. Whenever you are going to understand about any particular document, based on the frequency of the words, you are going to decide how the document is going to be processed. So with the information text statistics, we are going to understand the importance of the word frequency in the documents, and accordingly how the documents are going to be identified by the query entered by the user. Here when you try to understand significance of the word depend on its frequency in the document. Frequency in the sense how many times the word has repeated. So this is indicating the significance of the word depend on the frequency in the document. How many times the word has occurred, in how many places, in which places it has occurred, and what is the importance of the word will come to know. So that is about the frequency. And when you observe, there are so many statistical models are there. Statistical models of the word occurrences are very important in information retrieval. So statistical models are very important of the word occurrences, or very important, right? So statistical models of word occurrences are very important in information retrieval and are used in many of the core components of the search engines. Many of the core components of the search engines, such as how they are using as part of ranking algorithms, query transformation, and indexing techniques. So you are trying to understand that statistical models of the word occurrences are very important in information retrieval techniques and used in many of the core components of the search engines, such as ranking algorithms, query transformations, and another one is the indexing techniques. Now we will see the importance of the frequency of the words in the documents. One of the most obvious feature is of the text from the statistical point of view is that distribution of word frequencies. So from the view of the statistical point, we are trying to understand distribution of the word frequencies. They are very skewed. We know that if you see in a elaborated manner, there are few words that have high frequencies, that have very high frequencies. If you observe in some of the documents, some of the words will occur very frequently. So that is about the words that have very high frequency in some of the documents, and many words that have low frequencies also. When you observe some of the text documents, those documents having more frequent word and also the less frequent words. If you see in most of the documents, the two most frequent words in English, they are the and of. The and of account for about 10% of word occurrences. 10% of the word occurrences. So 10% of the word occurrences will be with the two words the and of. The most frequent 6 words account for 20%. Most frequent 6 words nearly about account for the 20%, and most frequent 50 words are about 40% of all the text. So if you observe here, you are trying to understand the frequency of the words present in the document and what are their percentages about the frequency of the words in the document. Here accordingly we are going to understand about one law, that is about Zipf's law. We are trying to understand as part of the text statistics. Here if you understand with one example, it will be very clear. Given a large sample of text, one half of all the unique words in the sample occur only once. If you observe specifically about one of the specific point, one half of all the unique words in the sample occur only once. They will occur only once. This distribution is simply described by Zipf's law. This distribution is simply described by the Zipf's law. So here what you are going to learn from this point is given a large sample of the text, typically it consisting of one half of all the unique words in that sample occur only once. This distribution is described by the Zipf's law. What the Zipf's law is stating and what it is about. So Zipf's law states that, try to understand this point very clearly, frequency of the rth most common word is inversely proportional to r. Once again I am repeating this one. Frequency of the rth most common word is inversely proportional to R. So here rank, R is rank, rank is inversely proportional to the frequency. Rank is inversely proportional to the frequency. So R is inversely proportional to the frequency. If the frequency of the word increases, rank will decrease. If the frequency of the words increases, the rank will decrease. If the rank increases, the frequency of the words will be decreased. So this is the fundamental basic point you kept in your mind. Accordingly, we'll try to understand the further concepts. So here, frequency of the rth most common word is inversely proportional to R. Otherwise, you are simply defining it. Alternatively, the rank of the word times its frequency f is approximately a constant. So here r dot f equals to k. So you are simply defining it as the constant. So r into f. So you are simply defining it as constant k. Here you try to understand in a more detailed manner the Gibbs law. What you are trying to understand is we are going to know about the frequency of the words and its importance in the documents. So generally, if you can consider any one of the document consisting of a lot of textual information, in that textual information, one half of the unique words that the sample occur only once. As part of the Gibbs law, what it is going to describe is frequency of the rth most common word is inversely proportional to R. Alternatively, the rank of the word times its frequency f is approximately a constant. So here R is inversely proportional to f. So Rf equals to 1. We can rewrite it, and Rf equals to k. So here this is about Gibbs law, and some more details if you found it when you go in an elaborated manner according to the probability of the occurrence. Now we will see according to the probability of the occurrence, what is the chance of occurring that particular word? What is the chance of occurring that particular word? According to the probability of the occurrence of the word, which is just the frequency of the word divided by the total number of word occurrences in the text. Try to understand in a clear manner. According to the probability of the occurrence, which is just the frequency of the word, divided by the total number of word occurrences in the text. So then you are going to define or decide the probability of occurrence of the word. If you want to decide the probability of occurrence of that particular word, you are going to calculate the frequency of the word divided by the total number of word occurrences in that text. In the case, Gibbs law is defining as like this. So R into PR equals to constant. Observe here, where PR is, what the PR is? The probability of occurrence for the rth ranked word. The probability of the occurrence of the rth ranked word, and C is constant for the English, and which is identically to 0.1. C equals to 0.1. Now if we are trying to understand according to the probability, so the probability occurrence of the word, which is just the frequency of the word divided by the total number of word occurrences in the document. You know that when you can take the statistics about one document collection, that document collection may be having unique number of words, and the word which number of times repeated, and the total vocabulary size. You are going to know about all those things, and accordingly you are going to calculate the probability of the occurrence. Accordingly, here simply you are writing the Gibbs law as R into PR equals to constant. So where PR is the probability of the occurrence for the rth ranked word, and the constant value is identical equals to 0.1. If you see here the curve, what it is indicating, it's a hyperbolic curve. Is hyperbolic curve. What it is representing, rank versus probability of occurrence for the words, which is assuming the Zipf's law. If you observe here on x-axis and y-axis, you will be having an x-axis rank you will be having by the decreasing frequency, and there is the probability of the occurrence. There is the probability of the occurrence. So the rank is less. So you know that what the Zipf's law is indicating, R is inversely proportional to frequency. Rank is inversely proportional to the frequency. If the frequency of the word increased, the rank will be decreased. So if you observe this diagram, you are able to identify this. So what it is indicating, the probability of occurrence is more than the rank is less, and obviously whenever the probability of occurrence is less, the rank is increased. So here this is the hyperbolic curve representing the rank versus the probability of the occurrence for the words. So this is only the fundamental you have to remind in your mind. Next, if you understand this one with one of the example from the old document collection, we will be having very clear idea to see how well Zipf's law predicts the word occurrences in actual text collections. Word occurrences in the actual text collections. We will use one of the example, AP 89. AP 89, we can simply call it as Associated Press Collection of News Stories. Associated Press Collection of News Stories. So this is the one of the example we are going to consider, and document collection we are going to use to know and to clarify about the Zipf's law. Before that, we need to have some of the idea and need to have the clarity about some of the terminology we are going to use as part of this Zipf's law and textual documents. So you are able to identify one particular word, vocabulary size. The vocabulary size is the number of unique words. Vocabulary size is indicating the number of unique words in the collection. They are the number of unique words in the collection. Even in this relatively small collection, in this relatively small collection, the vocabulary size is quite large. Nearly about, if you see, 2 lakhs unique words are there. 2 lakhs unique words are there. And a large proportion of these file words, or 70,000, occurs only once. The unique number of words you are going to observe, that's one, it is about 70,000. This is about statistics about Associated Press collection. So what you are understanding here, vocabulary size is indicating the number of unique words in the collection. Even in this relatively small collection, the vocabulary size is quite large. Nearly about 2 lakh unique words are there. A large proportion of these words, so 70,000 occur only once. 70,000 only occur once. The remaining will be repeated. So we will see this one as part of the statistics news collection. AP 89 statistics is all about this one. Total number of documents, so nearly about 86,678, and total word occurrences. So here 3 crores 97 lakhs of 49,179, and vocabulary size is about 1 lakh 98,763. What the vocabulary size is indicating, which is representing the unique number of words. So here word occurring greater than the 1,000 times, or nearly about 4,169, and word occurring once only occurs once is about 70,064. So this is text statistics about the news collection AP 89 statistics. As if you observe here, in the AP 89 statistics, if you can consider the most frequent 50 words from AP 89, most frequent 50 words from the AP 89, what you are going to observe here. So you will be having the word and it is representing the word. What are the words you are able to identify as the topmost of the 50 words from the AP 89 collection? The, of, to, a, and, in. Some of the words which we will use very frequently, those will be in the topmost. The, what is the frequency? Nearly about which is 2 crores, 2 crores, and here this is about it is about 24 lakhs, and here. So if you observe, this is indicating the topmost 50 words from AP 89 collection, most frequent 50 words from the AP 89 collection. So this is consisting of word, frequency, rank, and the probability, and the rank with the probability. So you are able to identify. And here if you observe the main thing, if you observe the frequency, the word which is having the more frequency having less rank. So R is inversely proportional to 1 by F. If the frequency increases, rank decreases. So if you come like this, you are able to understand in a very clear way. And the probability of occurrence is also more here, and the probability of the occurrence is also gradually decreasing. And if you see the frequency which is having less frequency, the rank is more. The rank is more. Here this is about the most frequent 50 words from the AP 89 collection, which is giving the clear information about the statistics with the Gibbs law. So which is indicating rank is inversely proportional to frequency. So as the part, just as it is a small description, so which shows the 50 most frequent words from the AP 89 collection together with their frequencies. Also what you are mentioning, frequencies, ranks, probability of the occurrence converted to the percentage of the total occurrences, and or into the PR value or calculating. And from this from that table, what we understand, we can see that Gibbs law is quite accurate. Gibbs law is quite accurate in that the value of R into PR value is approximately constant. It is approximately a constant. It is approximately a constant. In this slide, we are going to understand low frequency words from AP 89 collection. So if you observe here, the word frequency is about assistant, there is a word, and it is having the frequency 5000 around, and so there is a word sewers, and which is having the word 100, and toothbrush, it is having the word frequency 10, and harmath, there is a one word, and rank is obviously increasing. So if the frequency is increasing, the rank is decreasing, and the rank is increasing, the frequency decreases. So you are understanding this one in a very clear way, and you are also having the probability of the occurrence is also here, and the value of R and PR. So this is about the low frequency words from the AP 89 collection. And next, if you see some more elaboration about the previous one, it is possible to derive a simple formula for predicting the proportion of the words with the given frequency from the Gibbs law. So we are going to predict some of the formulas based on the information which is going to predict the information that how it is going to calculate. Here it is possible to derive a simple formula for predicting the proportion of the words with a given frequency from the Gibbs law. So there are some frequency of the words, accordingly you are going to predict the value. Here a word that occurs n times. A word that occurs n times has the rank Rn equals to k by n. So you know the fundamental, R is inversely proportional to 1 by f. R is inversely proportional to the 1 by f. A word that occurs n times has the rank Rn equals to k by n. In general, more than one word may have the same frequency. More than one word may have the same frequency. We assume that the rank is Rn is associated with the last of the group of the words. you try to understand. Whenever you see the example, it seems to be very simple, but as you go theoretically a little bit, you have to clearly understand it. So we have to assume that the rank Rn is the associated with the last of the group of the words Rn with the same frequency, In this case, the number of words with the same frequency n, how you are going to given as Rn minus Rn plus 1, Rn minus or n plus 1, which is the rank of the last word in the group minus, so observe the formula, which is the rank of the last word in the group minus the rank of the last word of the previous group of words with a higher frequency, Remember that higher frequency words have the lower ranks. This is an obvious point, we already know that. So here you are going to give the formula that which is the rank of the last word in the group minus last word minus the rank of the last word of the previous group of the words with the higher frequency. Now if you see, you can understand it here very clearly. So if you observe here, example word frequency ranking, and according to the Gibbs law, if you have the statistics, so the rank values are in increasing manner, 1000, 1, 1002, 1003, 4, 5, 6, 7, and the words associated with their concern, spoke, submit, like that. And if you observe the frequency is about 5100 and 5100, 5100, 5099. Wherever you go, the frequency is always inversely proportional to the rank. Frequency is always inversely proportional to rank, or rank is inversely proportional to the frequency. But here you are deriving that the word frequency. So to compute the number of words with the frequency 5099. So to compute the number of words, how many number of words having the same frequency of 5099, how you are going to calculate what we discussed in the previous slide. So you are going to take the value which is the 1. So what is the value, what is the formula you identified here, which is the rank of the last word in the group, minus the rank of the last word of the previous group. So if you observe here, what is rank of chemical? What is the rank here? 1006. You will be having the 1006. So if you want to find the frequency of 5099 is associated with how many number of words you want to derive. So here the rank is 1006 and minus the rank of the summit. Why you are taking the summit here? Summit. So which is the rank of the previous group word. So here observe, which is the rank of the last word in the group minus the rank of the last word of the previous group of the words with the higher frequency. So where last group of the words is this one, and what is the higher frequency you will be having? So that associated the rank is 1002. So what you are going to get? 4. So the words, how many words are associated? 1, 2, 3, 4. So the words which are having the same frequency, to compute the number of words with the frequency 5099, you can calculate like this. So this is about some of the basic formula you are deducting. Yeah, up to now we discussed about text statistics. As part of the text statistics, we come to know that what is the importance of the words frequency in the text documents, and as its main role as part of identifying the related documents from the web, we come to see, and we have seen that how the words has distributed as part of the documents and what is the distribution of the words by using the Gibbs law. As we already know that rank is inversely proportional to the frequency of the word. Rank is inversely proportional to the frequency of the word. If the frequency of the word increases, the rank is decreases. So up to now we discussed about Gibbs law and some of the important points about the Gibbs law. In this concept we are going to know that what is vocabulary and what is the importance of the vocabulary as part of the text documents, and we are going to identify the importance of the prediction of the words, how we are going to predict these words as part of the vocabulary growth. So we are going to know that what is a vocabulary growth, and we are going to state one of the law, Heaps law, and we are going to know that one of the assumption of the Gibbs law. We try to understand here what is the vocabulary growth. A prediction related to the word occurrence is vocabulary growth. Prediction related to word occurrence. So here we are going to make a prediction about the word occurrences. That is simply indicating and giving the information about the vocabulary growth. Prediction related to word occurrence is vocabulary growth. As the size of the corpus, so this is the new word, you understand, corpus is nothing but the text collection, so document collection, so that's what we are simply calling it as a corpus. As the size of the corpus grows, new words occur. As the size of the corpus grows, that indicates if the text collection is increasing, then the new words occur. Obviously we know that if up to now we are having 10 pages, if you see the 10 pages, you will be having some of the words and different words you are able to find. If 2 more pages are added, then obviously in the 2 more pages which are all added, you are going to identify some of the new words. So here now it becomes the 12 pages of the information. That is the point you are trying to understand here. As the size of the corpus grows, new words occur. Yes, very good. And there is an assumption about Gibbs law. There is an assumption about Gibbs distribution for words. How the words has distributed in the text documents, and what is the importance of those word frequency in the text documents, we come to find here the assumption of Gibbs distribution for the words. We would expect that number of new words that occur in a given amount of new text. Once again I am repeating this. The number of new words that occur in a given amount of new text would decrease as the size of the corpus increases. This is the one of the assumption about the Gibbs law. So what it is saying, number of new words that occur in a given amount of the new text would decrease. So the number of new words that is going to occur in the given amount of the new text would decrease. When it is going to decrease, the size of the corpus increases. When the size of the corpus is increases, the amount of new words would decrease. So this is about one of the assumption about the Gibbs law, and what we are going to know from this one is, and you are going to identify a relationship. The relationship between the size of the corpus, here the size of the corpus and the size of the vocabulary. So we are going to decide the relationship between size of the corpus and the size of the vocabulary, which was found empirically by Heaps, So this is the one of the law we are going to know. Here we are going to understand the relationship, and we are going to know about the relationship between size of the corpus and the size of the vocabulary, right? We will see, we will go into some details about it. As you observe here is an equation V equals to K into N power beta, where V is the vocabulary size, for the corpus of size n words, for the corpus of the size that is consisting of the n words, and K and beta are the parameters, where V is the vocabulary size, for the corpus of size n words, which is having the n words of having vocabulary size as v, and k and beta are the parameters that vary for each collection, that obviously vary for the each collection, referred to as Heaps law. This is, we are simply calling it as the Heaps law. If you go some more details about it, we will find some of the points regarding to the Heaps law, that typically values for k and beta, typically values for the k and beta are often stated to be so here typically the values for k and beta are often started to be between 10 less than or equals to k less than or equals to 100. The value of the k lies between, and beta is identical equals to 0.5. 0.5. So this is about the two parameters, k and beta parameters. Accordingly, we are just reconstructing and again going to know about the Heaps law in a detailed manner. Heaps law predicts that the number of new words will increase. Heaps law predicts that number of new words will increase. Number of new words will increase very rapidly. Number of new words will increase very rapidly. When it is going to increase? When the corpus is small. Now you try to understand that when the corpus is small, the number of new words are going to increase very rapidly. So this is the statement given by the Heaps law, and Heaps law is going to predict. The Heaps law predicts that number of new words will increase very rapidly when the corpus is small. When the corpus is small, and it will continue, to increase indefinitely. And it will continue to increase indefinitely, but at the slower rate for the large corpora. At the slower rate for the large corpora. So this is about the Heaps law. So as part of it, we just come to understand what is the vocabulary growth. That is about the prediction related to the word occurrence. So that's what the word vocabulary growth. As the size of the corpus grows, new words occur, we know that, and the assumption is about the number of new words that occur in a given amount of the new text would decrease. That will decrease as the size of the corpus increases, and the relationship between the size of the corpus and the size of the vocabulary was given by the Heaps, and here is an equation equals to k into n power beta, and where v is the vocabulary size of corpus of size n words, and k and beta are the parameters. This is simply referred to as the Heaps law, and the values are lies k value lies between 10 less than or equals to k less than or equals to 100, and beta identical equals to 0.5. Heaps law predicts that the number of new words will increase. What the Heaps law is predicting? The number of new words will increase very rapidly when the corpus is small, and it will continue to increase indefinitely. This is about the Heaps law. And next, this is the next topic we are going to know about, and we are going to estimate collection and result set sizes. We are going to estimate collections and result set sizes. So whenever you see this heading or the statement, we try to understand estimating collection and result set sizes. What it is depicting here, we are going to estimate the result set sizes. So when you are going to estimate the result set sizes, for example, you try to understand whenever you before the search engine, Google search engine, you want to find a particular information about on the search engine, then you search about that particular topic, and then you are able to retrieve the results. Here whenever you enter the text or web search query, what are the result sets you are going to retrieve? Here we are going to estimate those results, what is going to happen in the background and how this process will done. This is what we are all going to understand as part of results estimation and results set sizes, estimating collection and result set sizes. If you see here, this is the user interface you found at Google, that you enter www.google.com, then you are able to find one of the text box here. In the text box you entered the query like this: tropical fish aquarium. This is the query you have given, and whenever you enter the web search query and when you hit on the search button, you are able to retrieve the information as like this. So web results page, one of some of 38 lakhs results nearly you have retrieved, and they're all displayed as a ranked list of documents. So here results estimating collection and result set sizes. Now we will go into the details of it. Word occurrence statistics. Word occurrence statistics, what it is indicating, word occurrence. So for example, if you consider a text document, whatever the information you want to search there, immediately you are able to retrieve some sort of information. Very good. At the time you are going to consider word occurrence statistics. Word occurrence statistics in the sense, for example, you searched about the tropical fish aquarium. At the time you are retrieving about tropical fish aquarium documents related information, where you are going to find that how many times the tropical has repeated, fish has repeated, and aquarium has repeated. How many documents individually having the tropical and fish and aquarium. That's what the word occurrence statistics we are going to know about. So word occurrence statistics can also be used to estimate the size of the results from the web search. So here that will play an important role. Word occurrence statistics can also be used to estimate the size of the results from the web page. Immediately after the query. So here you enter the query. Very good, and you are going to retrieve the ranked list of documents. Meanwhile, you want to estimate. So that is what here. Immediately after the query and before the marked list of results, before the ranked list of results, an estimate of the total number of results is given. An estimate of the total number of results is given. Very good. Here we go in some more detail about it. To estimate the size of the result set, we first need to define results. What we are going to define? We first need to define the results. For the purpose of this estimation, what we are going to do is, a result is any document or a web page that contains all the query words. So this is the point I already told you while I was introducing this topic. What is it? We first need to define the results. For the purpose of this estimation, a result set is any document or web page that contains what it contains, all the query words. What the query? Tropical fish aquarium. They are all the words. Tropical fish aquarium, right? So this is about estimating. As part of the estimating, what we are going to identify. So we are going to identify a result is a document or the web page that contains all the query words. Some search applications will rank documents that do not contain all query words. Some of the search applications they will rank the documents. We know that there are so many search applications are there. They will be able to rank the documents that do not contain the query words. But given the huge size, they will give very huge size. But this is usually not necessary. So here some of the search applications will rank the documents that do not contain the query words. They are useful. They are simply useless, right? So when you go some more details about estimating collection and result set sizes, for example, if we assume that word occurrences independently of each other, if we assume that word occurrence independently of each other. As we see that in the previous slide, it seems to be like a small sentence. That's what web search query it is representing, that tropical fish aquarium. That's a query. When you see as an individual words, it consisting of tropical fish and aquarium. They are the three words present in the query. Here what you are trying to understand, if we assume words occur independently of each other, if they occur independently of each other, then what is the probability, and some of the probability related information we are going to know here. Then the probability of the document containing all the words in the query is simply the product of the probabilities of the individual words occurring in a document. Here we are going to give the probability of document containing all the words in the query is simply given as the product of the probability of the individual words occurring in a document. For example, if there are three query words, like as you see in the tropical fish aquarium, we are trying to understand there it is A and it is B and it is C to consider, and we are going to understand. For example, if there are three query words A, B and C, then P of A intersection B intersection C equals to P of A into P of B into P of C, where we can call A P intersection P of A intersection B intersection C is joint probability. It is the joint probability, or we also call it as the probability that all the three words occur in document and P of A, P of B and P of B. P of A, P of B and P of C are the probabilities of each word occurring in a document. Each word occurring in a document. Right, I hope you understand. So P of A intersection B intersection C is the joint probability, or the probability that all the three words occur in a document, and P of A, P of B and P of C are the probabilities of the each word occurring in a document. Each word occurring in a document. So this is the fundamental. You just understand and remember. And here when you go in little bit detail about it, a search engine will always have access to the number of documents that a word occurs in. Here we are going to know, as part of this searching process, we are going to understand as a document collection if that particular word is present in how many number of documents and what is the probability related. If you think about it, a search engine will always have the access to the number of documents that a word occurs in. So FA, it is FA and it is FB and FC. FA, FB and FC, and the document and the number of documents in the collection, and what it is? It is N, document collection N. So these probabilities can easily be estimated as, how you are going to estimate these probabilities? So you know that P of A equals to FA by N. Like that you can also write P of B equals to FB by N and P of C equals to FC by N. Then you can write simply FABC equals to N into FA by N, FB by N, FC by N. When you can solve this equation, you are going to get FA into FB into FC by N square, where FABC is the estimated size of the result set. FABC is the estimated size of the result set. So this is about estimating collection and result set sizes. And here one more point you come to find. Up to now we are just thinking that how the words, if they come individually and as part of the estimated result set collection, what you are going to retrieve. But here in this slide you are going to understand the co-occurrence of the words. Co-occurrence of the words. For example, there are three words: tropical, fish, aquarium. Now, if you can consider tropical as A, fish as B, and aquarium as C, then A and B occurs. So, the co-occurrence of A and B, and then related with the C, how it is going to work, and as part of it, how you are going to retrieve the estimating the result set size. So, this is what we are going to understand here. Better estimates are possible if word co-occurrence information is also available from the search engine. Word co-occurrence information is also available in the search engine. Obviously, this would give exact answers for two word queries. So, what you are going to understand here, this would give exact answers for the two word queries. Exact answers for the two word queries. Two word queries in the sense, so as you find here for the two words tropical fish, then aquarium, two word queries. Obviously this would give the exact answers for two word queries. For longer queries, we can improve the estimate by not assuming independence. For the longer queries, so we are not supposed to take for longer queries, we can improve the estimate by not assuming the independence. So that's what you are going to take the co-occurrence there. And here in general, the three words, if you represent P of A intersection B intersection C equals to, how you are going to rewrite it here, P of A intersection B into P of C that A intersection B. Once again I am repeating, P of A intersection B intersection C equals to P of A intersection B into P of C by A intersection B. A intersection B. Here try to understand. When you see here, you observe P of A intersection B is what? P of A intersection B is the probability that the words A and B, the words A and B co-occur in a document. So P of A intersection B is the probability that the words A and B co-occur in a document. So for example, tropical and fish, they occur in a document, and P of C by A intersection B is the probability that the word C occurs in a document. The word C occurs in a document given that the words A and B occur in the document, right? So here you will be having only two words, P of A intersection B and P of C by A intersection B. As part of it, you are understanding P of A intersection B is the probability that the words A and B co-occur in a document, and P of C by A intersection B is the probability that the word C occurs in a document given that the words A and B occur in the document. A and B occur in the document. Once again I am repeating that P of C by A intersection B is. The next concept is about document parsing. Document parsing. So this is the one of the word as you already familiar while we are discussing about the text to transformation phase. We discussed a few of the concepts. Have you remembered those concepts? So some of the concepts as part of the text transformation, whenever you are going to transform the text, what are the steps you find there? One is parser, stopping, stemming. So they are the words you already studied about it. As part of it, we are going to understand. So what is document parsing? As part of the document parsing, just we will have some overview about it, what we are going to do as part of the document parsing. As part of the document parsing, which involves recognition of the content and structure of the text documents. As part of the parsing, what you are going to understand and what you are going to observe is that recognition of the content and structure of the text documents. So document parsing involves the recognition of the content and structure of the text documents. So you are going to recognize the content and the structure of the documents as part of the document parsing. The primary content of the most documents, is words. As we know that any document having a huge number of the words, the main content is the words that we were counting and modeling. As we just discussed about Zipf's law. What the Zipf's law is indicating? If the rank decreases, frequency increases. If the frequency decreases, rank increases. So here we are counting and modeling using the Zipf's distribution. So the main content of the document is the text. Obviously you are going to count and modeling using the Zipf's law. Recognizing each word occurrences in the sequence of characters. So I hope you are remembering about this point. This is also we have discussed. So what is tokenization? The process of processing of text tokens. So here recognizing each word occurrences in the sequence of characters in a document is called tokenizing, or what we can also call it as lexical analysis. As part of this one can recognize each word occurrences in the sequence of the characters, in a document. That's what we are simply calling it as a tokenizing or lexical analysis. So along with the text, other types of content in the document such as metadata, images, graphics, codes, and other tables also present in the documents. And the metadata content includes document attributes such as date, author, and most importantly the tags that are used by the markup languages to identify document components. If you want to identify the document components, you are having the metadata contents includes document attributes such as date, author, and most importantly the tags. And when you go in more detail, so just we are trying to heard the word tags. So popular markup languages will be having, so HTML will be using so many tags in the HTML, and so that's what hypertext markup language, and in XML extensible markup language. Here what is going to do as part of the processing of this text, you can also observe here the parser uses tags. The parser is going to use the tags and other metadata. It is going to use the tags and other metadata recognized in the document for interpret the document structures. It is going to interpret the document structure on the syntax of the markup language. Once again I am repeating, the parser uses tags and other metadata recognized in the document to interpret the document structures. If you want interpret the document structures based on what? Syntax of the markup language. This phase we are simply calling it as a syntactic analysis. Based on the structure it is going to be identified. So that's what you are calling it as a syntactic analysis. And to produce a representation of document that includes both structure and content. Obviously it is having both structure and the content. Next, so for example, HTML parser, or the HTML parser interprets the structure of the web page. It is going to interpret the structure of the web page as specified using HTML tags. And creates a document object model DOM. So creates a document object model representation of the page that is used by the web browser. So here the example is indicating HTML parser interprets the structure of the web page as specified using the HTML tags and creates the DOM document object model representation of the page that is used by a web browser also. When you see the concept of tokenization in some more detailed manner, what we are trying to understand is about tokenizing is the process of forming the words. So it is the process of forming the words from the sequence of characters. We are simply calling it as tokenizing or tokenization. So tokenizing is the process of forming the words from the sequence of characters in the document. So word was defined by any sequence of alphanumeric characters of length 3 or more. So generally, if you want to call it as a word, it is a collection of some characters more than 3. We are simply calling it as a word, and terminated by the space or other special characters. So if you want to call it as a word, so generally it is having of length 3 or more, and one word to another word there is a special character or the space you are able to understand or identify. And here there is an example, the text consisting of a document consisting of the text like this: Big Corps 2007 biannual report showed profits rose 10%. Then when it goes, this text goes with the tokenization process, the tokens will be generated like this: Big Corp 2007 annual report showed profits rose. So as part of the tokenization process, what is going to be happened, some of the strip punctuations are going to happen, and some of the spaces are going to removed, and stemming, stopping, these are all as part of the document passing will be done. As part of the tokenization, it is going to process the sequence of the characters to forming the words. Process of forming the words from the sequence of characters in the document. Here these are all the different tokens. And now we will see some of the issues present in the tokenization or tokenizing. Some examples of issues involving tokenizing that can have significant impact on the effectiveness of search. There are some of the issues present here. What are the issues you are observing as part of the tokenizing here? Or one is small words. What is small words here? As part of a sentence or as part of the textual information, there are some of the small words which are 1 or 2 characters. Can be important in some queries. They are very, very important in some queries. Usually in combinations, they are in the combination with other words. So 1 or 2 letters, they are in the combination with the other words. For example, you won't say so XP, okay, Ma, PM, and king, Epson. Different words you are able to identify so as 1 or 2 characters. El Paso, Master P, GM. Like this, there are 1 or 2 character words are able to be identified, and whenever the processing is going on, this is one of the difficult tasks to work with them, and these characters will be removed sometimes. That is giving one of the bad impact on processing of the text, right? And another one, both hyphenated and non-hyphenated. One hyphenated and non-hyphenated, which is going to form many of the words are common. In some cases, the hyphen is not needed. Generally. For example, eBay, Walmart, Act2X, CD-ROM, T-shirts. So generally we can use. At other times, hyphens should be considered either as part of the word or word separator. Sometimes you are going to consider this as part of the word or separator. For example, so Winston Salem, Mazda RX-7, e-cards, and pre-diabetes, T-Mobile. So like that. So many words are there. So here if you observe, both hyphenated and non-hyphenated. Whenever the text tokenization is going on, so there are also some of the issues with hyphened words and non-hyphened words. And there are some special characters. With the special characters, they are also important part of tags like URLs, and codes and other important parts of documents that must be correctly tokenized. That must be correctly tokenized. So there are some of the special care like http www.google.com, like that URLs. There may be some special characters. Whenever it is going to process the special characters, it is also facing some of the difficulties. And capitalized words can have different meaning from lower words. So some of the words which are having capitalized words, they will be having the different meaning with the lower case letters. So for example, you want to say bush, and one is the apple. So these are the this is the one of the issue you are going to identify as with the capitalized case sensitivity. And another one, apostrophes. As part of the textual information, you are able to find apostrophes. Sometimes there may be need of these apostrophes as part of the text, and whenever the processing is going on, it is also a problem that apostrophes can be the part of the words, a part of a possessive, or just a mistake. For example, Royce Donmel and can't, don't. 80s, here you are using apostrophe as men's, and hats, masters, degree. So these are the different words with the apostrophes. So there is also an issue while working with the apostrophes also. And numbers. Numbers can be important, including decimals. For example, Nokia 3250. This is also important. Whenever the tokenization is going on, that is also need to be considered the numbers, like Nokia 3250, like top 10 courses, United 93, QuickTime 6.5 Pro, like that. There are so many examples. So this is also play an important role as part of the tokenizing process. This is also one of the issue you come to find dealing with the numbers. And next, periods. So dot or the period, you can see period can occur in numbers. Generally it can occur in the numbers like 10.570, 9.70, and abbreviated forms, example IBM. So here you are able to identify, and the PhD URL ends with the sentences and other situations also. So these are all the different issues whenever the tokenization is going to happen as part of the text. So small words, they will be identified, and both hyphenated and non-hyphenated, and there are also special characters and capitalized words, so case sensitivity, and apostrophes, and with the numbers, and also with the periods. So these are all the different issues we can come to find across as part of the tokenization. Next concept is about stopping. What is meant by stopping? The word having a meaning that going to stop. So what you are going to stop, as part of stopping, what we are going to understand. So as we already know that there are so many huge collection of the documents. In those documents, some sort of text is repeated more number of times, so which is repeated frequently without necessity of repeating number of times. So here those words will be stopped. Here when you go with some points here, human language is filled with function words. So generally whatever I am talking or whatever I am writing, that is filled with the function words that have little meaning, that is having the little meaning apart from the other words. So generally there are some of the words which are having the clear meaning. Apart from the words, there are some of the words they are not having the clear meaning, but when they can associate it with some words, then only they will be having a full-fledged meaning. The most popular are the, a, and, that, and those are determinants. So you see here some of the words you are able to observe, they will be repeated more in the any text documents. So there are two properties of these function words cause us to want to treat them in a special way in the text processing. While the text processing is going on, the two properties of these function words can cause us to want to treat them in a special way in the text processing. So first one is the disk space, and the second one is commonness and their function. So So keeping track of the quantity of these words in each document requires a lot of disk space. So whenever you observe the most frequently the words occur the and they will be occur more frequently in any document. So they will, if you repeatedly consider them, they will occupy the more disk space. And second, both of their commonness and their function, those words rarely indicate anything about document relevance on their own. So that indicating without any support of the other words before a word or after the word, the pre-word or post-word, there is no meaning, a particular meaning for the particular words. So they will be definitely need to depend on the other words even. So that is about the commonness and their function. And here they are the two properties of these function words cause us to want to treat them in a special way for text processing. One is disk space and another one is the commonness and the function. And here you can also call the function words. In information retrieval, these words, function words, have a second name as what we are calling them as stop words, having another name, stop words. So what are the stop words? Here we can call the stop words because text processing stops when one is seen and they are thrown out. So whenever the text processing is going on, whatever the words which will be occurred very frequently, they will be stopped immediately. So that is thrown out. Throwing out these words decreases index size. Throwing out these words obviously decreases the index size, increases retrieval efficiency, which increases the decreases the index size and increases the retrieval efficiency, and generally improves what? Retrieval effectiveness. So improves effectiveness and increases retrieval efficiency and decreases the index size. So that's the one of the advantage when you go with the stopping. Removing too many words will hurt retrieval effectiveness in particularly frustrating ways for the user. Sometimes whenever the user is trying to get the information from the Google, he is unable to find what he is searching for. So he is getting the information, but this is not relative information, because some of the times as part of the tokenization, if the some of the words, useful words, are removed at the time, that may be the very difficult task to get the information whatever you want to retrieve. So that's what removing too many words will hurt retrieval effectiveness, in particularly frustrating for the user. And last, if you observe, the stop word list can be constructed by simple using top n most frequent documents in the collection, as we already seen an example. So the top 50 frequent words from the AP89 collection. So the first word is the, so which has repeated more number of times, which is having the less rank, more frequency having the less rank.